All right, so welcome back. So when we left off, we had finally formed that system of equations that we needed in order to solve this optimization problem. And again, just now that we have our three equations, let's go ahead and walk through some steps. So step one is we're going to take the very first equation and we're going to solve for lambda. All right, let's do that now. So if we're going to solve for lambda, so that's not bad. It's just we need to divide both sides by 4. Oh, I apologize. I think it's solve for y. We need to solve for lambda. So what do we got there? We got a probably easier to multiply, get rid of that fraction. If we just multiply by the reciprocal of 2/9 is 9/2. So multiply by 9/2. That will give me, so that'll be 36/2, right? Y, which basically is just 18, equals lambda times x. So that's 18y equals lambda x. And of course, you're trying to get lambda by itself, so divide by x, and we end up with lambda is equal to 18y over x. All right, so that's step one. And what we're going to do is we're going to take this 18y over x and we're going to substitute it in for lambda in the second equation. At that point, so after we sub that lambda into equation 2, it's up to you, but you can solve for x or y. But take a look, and this does take a little bit of practice, because take a look at because we're going to end up subbing something into the third equation, right? But just as some practice, we might want, I can either solve this equation, the third equation for x, or solve it for y if I want to. But just remember, you can also sub in for x and then square it. You can sub in for y, then square it, or you can just sub in for x squared as well. But I'm getting too far ahead. Let's go ahead and do that now. So we got 4x is equal to 1/8 lambda y. I'm subbing in for lambda. So now I have 4x is equal to 1/8 18y over x y. Okay. So now let's go ahead and it's up to you if you want to solve for x or if you want to solve for y. I'm going to solve this for what do I want to do? I think I'm going to just solve it for x. So, all right. So, first things first, let's go ahead and start to simplify these equations here. So, I got 4x is equal to, well, I got, I'll go ahead and write this as 18y squared over 8x. All right, if we multiply all that out. And of course, 18 and 8 share some common factors. So I got 4x is equal to, we got 9/4, right? 2, so yeah, 2 goes into 18, 2 goes into 4. All right, so yeah, 2 goes into 18, 9, 2 goes into 8, 4. So 9y squared x. All right, and we still got to, since we're trying to solve for x, let's go ahead and divide by 4. Divide by 4. So we end up with x is equal to, what is that, 9, so we got to flip. So to divide by 4 is to multiply by 1/4, which means ends up being 9/16. We still got y squared x. Well, I still haven't solved for x, right? I still have an x here. So what I'm going to end up doing is multiplying by both sides by x. So, and then I will basically have solved for x squared at that point. So times by x times by x. So x squared is equal to 9/16 y squared. All right. Now we're going to take this 9/16 y squared on the next page, and we're going to substitute it in for x squared in the third equation. All right, so we're going to substitute 9/16 y squared in for x squared. All right, ready? So 9/16, let's write it this way. Let's write it as 1/9 instead of divided by 9. So 9/16 times 9/16 y squared. So 1/9 times 9/16 y squared plus y squared over 16 is equal to 1. All right, well, not bad. We just, we end up, we just got to combine like terms. We got to, distribute this out. We end up with y squared is equal to 8, or y is equal to, it's plus or minus. Again, we'll throw out the negative because x and y have to be greater than 0. So y ends up being 2 square roots of 2. All right. So we have y, and now what we're going to do is we're going to use y to solve for x. But notice, come back, follow me here. Notice that if I go back to this equation, I know that y squared is equal to 8, so I can plug this 8 in here for y squared, and then solve for x. So if x squared is equal to 9/16 y squared, let's do this. Let's just plug this 8 in for y squared. So x squared is equal to 9/16 times 8. In other words, x squared is equal to 9/2, or x is equal to 3 over the square root of 2. Quite beautiful. Do you recall these values? X and y, this is what we got in the previous video as well. So if you want to find the maximum area, let's just go to the area formula. So area is equal to, of that rectangle, is equal to 4xy. And we're going to plug in for x, we're going to plug in for y. So area is going to be equal to 4 times the 3 over the square root of 2 times 2 square roots of 2. And there it is, your maximum area. This is the Lagrange multiplier technique. This is the method. Optimization, right? Optimization gets messy when you increase the amount of constraints. But the Lagrange method, especially when you have more than one constraint, is the way to go. And as some of you have heard me say before, most applied mathematics ends up coming down to a system of equations. And that is exactly what happened, that we were trying to find a maximum or a minimum or some value, and it ended up coming down to a system of equations. Now, Lagrange equations are not always linear. So sometimes you need to, it takes just quite a little bit of practice, right, to get used to solving them. But what I'm going to do is I'm going to erase what I had here. I'm going to give you a problem, and then I'm going to take a break on the video. Okay? I'm just going to give you a problem, and why don't you just try it? Right? It's up to you. I don't particularly care whether you just go to the next video or not. But you'll get better at this when you start trying it. So let me give you f of x, y is equal to x squared minus y squared, and it's going to be subject to the constraint 2y minus x squared is equal to 0. So your goal is, can you use that Lagrange method to find, to maximize f? Right, so we want to find the max of f. So can you maximize this function under this constraint? Can you try that Lagrange method, see what happens, see if you can do it? At the beginning of the next video, I will show you how to work it, but I guarantee you'll value that solution a lot more if you try it first. See you there.